No, I don't think they hear us. I think it's better if we can kind of, code it. But I would like to ask the second question to Professor San, anyways, on the foundation models. So the commonly asked questions among the participants is the following: large-scale pre-trained models, including multimodal models and foundation representation models, show impressive skills in everyday domains. However, industry inspection involves fine-grained recognition tasks, as well as sensors other than regular cameras. Can such foundational models be utilized for industrial inspection tasks? Professor San, to hear your comments on this.
All right, thank you. You can hear me clearly, right? Can you hear me?
I hear you, but not the room. Yeah.
Not the room. Okay. 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 So.
1 second.
Okay. 1 second. Okay. Okay. Sure. Sure. Yeah.
Normally it should be.
Okay.
Yeah, it works.
Let me keep talking. Now it's okay. The room can hear me.
Yes. We all hear you.
You all hear. That's great. That's great. Okay, thank you. At first, I'm honored to be invited here and participate with the discussion. I think it's a very important topic, the vision for the industrial inspection, especially as far as I can see, it's kind of full house, right? So I'm very happy. I actually, as I listened to my own talk, actually, it's a little bit faster than usual because I really want to control that within 20 minutes. I just want to give some explanation. You don't speak that fast for whatever reason. Okay, and for the issue you mentioned and want me to comment, also quite important about the foundation model. And I think the foundation model, like the segment, anything like the SAM and also CLIP that Ravi mentioned, they all already show very good capacity in general domain. So that's not a question. I think foundation model definitely will help out the industrial inspection. But the question is, can we leverage those models for industrial inspection, and also what kind of challenge we face? I mentioned briefly in my talk, but now I've got a chance. I want to elaborate a little more. I think the one challenge, the first challenge is the diversity of the industrial inspection tasks. And I think it's not different from we do academic research, we do some general independent tasks, like we do prediction and then prediction, clustering, and the other. But I think the industrial tasks, they have very specific, each have very specific requirement. But at the same time, they also kind of interrelated. It's like anomaly detection, for diagnosis, segmentation. They are very different requirements, but at the same time, they are somewhat related. This is challenge, also opportunity. I just wondering, the research is different from those research for general domain, and then there's still something we need to tackle. At this point of time, one size fit all, I think it's very difficult, but I think that's we should toward that direction. So multitask is one of the challenge we can tackle. And by the way, I also mentioned those tasks, especially for industrial inspection, this task seems to also have it's not just interrelated, also in sequence. We do the detection and segmentation, diagnosis, and even later different kind of decision making. This is some sequence. I think that's somewhat related to a hands-on, and in Georgia Tech research group, they're doing the multi-stage process. I think there's some relation with that. So that's one challenge. Another challenge is, of course, is the very data modalities. We have before we use image data, but also combined with sensor data, 3D point cloud data, and those data fusion. Again, I think the Shanchong's research group doing the data fusion for years, but right now I think that's somewhat different scope. We talk about multi-model data fusion and combine data from the multiple resource, combine data from the multiple source for the analysis. I think that's bringing a great opportunity for this. So one is multiple source data, and another is multiple task. I think that both challenge we can tackle. I think that for the short-term benefit, that opportunity bringing by the foundation model is quite obvious. One is can enhance the detection accuracy. Theoretically, before we only use image, but now we combine with different modality and with more information integrate together, we're supposed to be able to increase the detection accuracy. So I think that's the right direction. And the second opportunity is to generate synthetic defective samples. I mean, there's right now we can create a real realistic image to augment the training data set. As I hear some talk about this, and this one also an immediate opportunity. And the third one is about the assist annotation. And before we need a lot of labor to do that. Right now, we based on foundation model, be able to assist the annotation to reduce the time and labor for the data set labeling. So this is, I think immediately we can see some advantage. In terms of, I also mentioned the strategic consideration, I mean, how to long-term add value to the business. Something I can think of is if we really build up those foundation models to handle multiple source and multitask, I think that take time because also have many challenges. But if we really have that will definitely adding a lot of value for business for industry because of the dynamic manufacturing environment. Right now, we need to adapt to the changing environment, also the new task, new customer, a new product. So at this point in time, I always like build new model for each new task. But right now, if we really have such a multi-task foundation model, I think that will be able to quickly adapt to a new task. That definitely will help industry, and also in long term can simplify the system. I mean, can reduce the maintenance time and improve the reliability. I mean, talk about the future because you have one model. But right now, I have so many small models to manage and maintain. So I think basically that's my comments. Thank you.
Thank you very much for your comments. Actually, this question received, we received very similar questions. So I would like to ask a very related questions to Dr. Vemulapalli. He kindly presented actually a very relevant research this morning on aligning visual foundation models to specialized domains like Eurosat. But the question is, foundation models are typically suitable only for commonly used data domains, yet specialized sensors are commonly needed in industrial inspection applications. So are there breakthrough developments, recent developments in research that can help in applications where adapting pre-trained models to specialized domains or sensors are needed? So do we have any recent developments that caught your eye?
So let me say this first. I mean, I think the foundation models come with the promise that, I mean, they're popular because everybody assumes or they come with the promise that they can be easily adapted. I think the fact is that they can be easily adapted maybe compared to models that we have seen so far, because these models are trained on a lot of data that's from different domains. Though I wouldn't say that out of the box, maybe many of you who have experimented might have realized that out of the box, they may not directly work with the specialized sensors that you folks are trying to work with. But I think the promise is that they can be quickly adapted. Maybe you don't need a lot of data to adapt them. And of course, there are many techniques these days available to adapt them, not just the typical fine-tuning things, but things like LoRa adaptation, visual prompt tuning, which has become popular in other domains. They can be used to adapt these models maybe with less amount of data, not like you need insane amount of data which was used to train them. So I would say in that sense, they provide the promise. Though I would still say the key thing here, at least based on my experience, the key is data. I mean, whenever we are trying to adapt a model, end of the day, it needs to learn the new domain. It has to see something from the new domain. So what data is used matters a lot. So maybe the key question here is that how to find the right data to teach the model without giving a lot of data. I mean, we want to identify a little bit of data that is most relevant to teach the model. So I think I touched upon that in the talk in the morning, where if you have few samples from your target data, maybe you can use some techniques based on retrieval to create bigger data sets that look like your target domain, and then use these things to teach or adapt the models to your task. So I would say, I mean, that's what I have seen in most of the domains where foundation models are successful. I don't know, the key seems to be data. If you find relevant data, you get successful there. So maybe that's the direction a lot of us also needs to think in this community, because I find that coming from other domains, I find that the amount of data, the scale of data sets is fairly limited in the manufacturing domain. Maybe that's something that is the main bottleneck here. And if you scale that up a little bit, I think we can easily adapt these models and then see the success we are seeing in all the other domains.
Thank you very much for your comments and insights. Unless there are other comments on this topic, I would like to go on to the next topic on emerging tech. And I would like to direct this question first to Professor Colosimo. So the question is, what emerging technologies do you believe will have the most significant impact on manufacturing infrastructures in the next few years? Thank you very much.
So I'm moving there so that you can, let's say, listen to me. Thank you for the questions. I saw a lot of convergence going on. On the one side, all the inspection and metrology solutions are becoming more accurate at high resolution. So they are cheap, but can be an amazing job when you are integrating in manufacturing processes. And so you can really enjoy a lot of images coming from not just the, let's say, traditional visual image, but also thermal imaging. We are also playing the game with polarized image, so trying also to have some sort of additional insight. And I saw a lot of integration also on X-ray CT that are going to make a difference also in case you want to have some idea of density. So from the viewpoint of sensors, I saw an amazing, let's say, set of opportunities coming out. And clearly there's also all the amazing new solutions coming, not just for 3D printing that I'm a big fan of, but also welding. All traditional processes are experiencing a jump also in the way in which they can be sensorized. On the one side, there's also all the knowledge that is expanding on AI and generative AI. So my main concern is about hype. I mean, so companies come to us with a bunch of data, put the data on our desk and say, please solve the problem. Sometimes, most of the times actually, the problem is not well defined. So they actually don't know what type of problem they want to solve. And most of the time they are not dealing anymore with image, but with video image. So I think the dynamic, it's going to play the game, especially if you can experience, let's say, some spatial and temporal sequence of image, which is asking us to move a little bit a step ahead, let's say, in the way in which we are managing data. So my main concern is that clearly you can solve many problems. Some of them are even easy to be solved with traditional solutions without creating complex deep learning solutions. Sometimes I'm also a big fan of going back to simple features-based statistics that can be quite robust, let's say, in terms of what they can provide and are really good and explainable. I'm only saying that sometimes, even just looking to all the posters, I saw a lot of different variation of algorithms. Sometimes as a manufacturing lady, let's say, I'm a little bit confused because they look more like sometimes a tuned heuristic. And so I wonder what is the type of knowledge we are really understanding in tuning all these type of new solutions that we can gain. So as a community, especially from the academic viewpoint, I think we should make an effort for, let's say, also increasing the knowledge about what we are doing, what type of solutions are good for what type of problems, especially for the type of data, because abundance of data, it's now the reality. I mean, it's no more a dream. And so we really need to be careful in defining the best track depending on the problems we need to face. But there's for sure a lot of questions coming from industries and a lot of research that it is needed to, let's say, help them finding the right answer to their problems. So I see a lot of opportunities in the future.
Oh, sorry. So thank you very much. As a machine learning person, I have taken notes, sensors raising, new sensors coming. We need to be able to extract video information, dynamic information, and we need models that we can understand. I think this is a very, like I've seen a lot of talks yesterday as well, emphasizing the same thing. It's very important to understand what we are doing, and we are using big models. The next topic is very related, actually. So, as Professor Colosimo mentioned, sometimes there can be a huge gap what is needed in real world data and what we do in vision and machine learning conferences. So the question I would like to ask to Dr. Thomas is about the gap between industry and academic research. Maybe we can also see this as production systems, manufacturing systems versus academic computer vision research. What are the current primary challenges in applying AI models for automated industrial inspection, and how do these challenges highlight the gaps between academic research and industry needs? So.
Thank you. Hi, everyone. My name is C. Thank you for the question. So this is about the gap between research and industry applications. I think everyone here knows there are a lot of gaps between what most people are doing in academic research and what's going to have impact and actually be useful in a factory setting. And there are a few reasons for that, but I think to me what comes to mind most is the requirements, especially of inspection. The accuracy requirement is extraordinarily high. It's the kind of high that when you tell most researchers, they kind of laugh and want to walk away. But we do still need to solve these problems. So we need to have automated inspection, machine learning models deployed in the factory, which can detect all defects with basically no overkill, no mistake, no false positives, no false negatives. Any false positives that we capture will lead to slowing down what's happening in the factory, right? And false negatives are completely unacceptable. You can't miss defects that may arise. So in that like narrow space where you live, if you want to deploy a machine learning model in operations or in manufacturing, you have to be very aware of what you're trying to do. And I think one of the important things to think about is that it's not all bad news. Because when we think about what metrics are important, it's not just maybe we're deploying a semantic segmentation model. We want to identify scratches or dents or defects, and we need to know what size they are, how many pixels or how many microns across, in order to know if that's kind of if that's something that we need to flag or call out. So usually when we're training our models, we're looking at MIOU or we're looking at some pixel level accuracy, some pixel level measurement. When I tell my leadership, okay, we have 99.99 whatever percent capture, the thing we're talking about actually there is if there is a problem or a defect in my image, I identified it. So sometimes actually, when you're thinking about applying cutting edge methods that you see that work really well in academic research on some natural images like cityscapes or ImageNet or something like that. Okay, that's really exciting. Here, the thing that I care about is that you're actually seeing the defect and not necessarily that the IOU is perfectly captured. So I think I'm not sure that I explained it very well, but I think trying to clarify in industry exactly what metrics we care most about and how those differ from some of the metrics that you might report in your academic research. And trying to sort of close that gap to make it so that the things that you capture are the things that matter most on the line or in production. So I think those are two of the big things. I think the other question was also about like what other opportunities there are to sort of keep moving. I think we all know here that there are a lot of opportunity in, there's a lot of opportunity in manufacturing machine learning. The main things that matter, Shinhari actually touched on earlier today. So we have accuracy. We also have this fact about a lot of the data that you see, that you've looked at today, that the specific images might be quite high resolution and they might be quite complex. But actually the difference between images is usually nominal at best. Most things that people manufacture look the same as the thing that they manufactured yesterday. So that difference is a major difference between kind of these natural image data sets and the kind of data sets that we care about performance on in manufacturing settings. I think there's actually a parallel there to medical imaging or to other kind of domain specific fields. And that's also something that's important to keep in mind, like the kinds of differences that arise often are the kinds of differences which make something that looked really good on cityscapes look really bad in your manufacturing data set or your medical data set. So I think there's a lot of opportunity there. Also, as we manufacture, maybe the device changes every 6 months or every 12 months, we have some kind of refresh. That model accuracy requirement doesn't change. So just because something changes, maybe I changed out a component, that doesn't mean that I can suddenly start missing defects that I need to capture. So I think that the kind of adaptive learning or generalization or domain transfer, these kinds of questions are really important, but the domains are really close together. Like last year's device might be very similar to this year's device, and the defects might also be very similar, but I do need to be able to adapt from one to the other. And I think there's also a lot of opportunity there. I'm sure there's more opportunity that I've missed. Something that's final note that I want to make is that in manufacturing, the deployment also matters. And so you're not going to be deploying some kind of massive model or something that would be very slow to infer directly into your factory. So when you think about some really cool solutions that are really complex, it's important also to consider some of the constraints. You can't change software that's running in the factory like at will. There's a lot of change control in any kind of industrial setting. And so some of the active learning, like some of the ready to adapt methods may also not be the perfect solution in a manufacturing setting. So I hope I've outlined some of the opportunities that we see when it comes to closing that gap between most academic research and where we're really going to see impact in the industrial setting. Thanks.
Thank you very much. Very, very insightful answer. I would like to continue with a question that is very much linked to this. And I would like to ask to Dr. Bergman. So more specifically, yes, we talked about the gap between manufacturing needs and academic research in machine learning. But what do you think would be desirable to have in new public benchmarks to drive the industrial inspection and anomaly detection research in a direction most valuable for addressing the open problems? We are very curious about your comments as an expert in benchmarks and data sets, among other things. So thank you very much.
Hi, everyone. Thanks for having me on this panel. And yeah, I first want to start generally emphasizing that I still think there's like a pretty significant need for more diverse and carefully designed benchmark data sets in this industrial inspection and anomaly detection area. So I think there are already now quite a bit of benchmarks out there, but I think there's still room to push further for better data sets. And I have a couple of points. So I think the first key improvement that we should make is like we should really make sure that the benchmarks really reflect the practical challenges in the industrial scenarios. Like I think it was already mentioned just now also that like many existing data sets, they are collected in like really controlled laboratory environments in the research field. But I think in real production settings, you have other things to deal with, like slightly changing conditions in light when you run your model. Also like small changes over time. So I think a benchmark really needs to reflect these things. And so that actually the model that you develop is also useful for practitioners when they deploy it in the factory. And I think a model needs to be basically able to handle these small domain shifts without needing like frequent retuning when you run it in a factory. And I think it would be really good to have this reflected in benchmarks as well. So maybe not just have training and test set like capture on the same day, you just split it randomly away and then you test your model, but maybe purposefully like try to include these small domain shifts that you would also expect to see in practice. Another point I think that is really important and often overlooked in academic settings, I think, is inference time and memory efficiency. So I think it would be really great to have a benchmark that fairly evaluates not only the detection performance of the models, but also like how much memory they consume and how fast they actually run, because that would prioritize this also in like when you write a paper. I think that would be really good to have this explicitly measured in a benchmark. And so that you don't just favor models, I don't know, that ensemble a lot of things together and have really good performance, but yeah, it would be really hard to use in practice. And I think this comes with a lot of challenges for a fair benchmark because yeah, measuring memory consumption and runtime fairly is not that easy. So ideally, if at all possible, like it would be great to have like this explicitly in some kind of evaluation platform integrated, that maybe people submit their models there and then everything is measured in a really fair and comparable way. I think that would be great. Third aspect, I think, is inclusion of more diverse like sensor modalities. I think at the moment the community is heavily focused on RGB image data, but I think it was already mentioned multiple times that now industries are also utilizing more advanced sensor setups like 3D sensors, hyperspectral data, or X-ray, among other things. So each of these modalities, I think, provides like different insights in different types of defects. So having more of these out there in public benchmarks would be a good thing. Also for this whole area of multimodal fusion, like bringing the different modalities together. Also in terms of pre-trained models, we need more pre-trained models for different sensor data. So if a benchmark could include this, I think that would be a good thing. And another thing I would like to stress is threshold estimation, actually. I don't think threshold estimation at the moment is part of many public benchmarks, but I think in a real world setting, at some point you need to decide on a threshold to make a decision, is this a defect or not? And at the moment we use a lot of threshold independent metrics that integrate this threshold estimation out, basically. But I think it would be a good thing to bring this back into a benchmark, maybe as a separate metric. Because in my mind, threshold estimation is also part of the anomaly detection method. If a method is good at estimating a good threshold, then it's a useful method in practice. So if a benchmark could include threshold estimation as a separate task, maybe, I think this would bring a lot of value. Yeah, I think those are my points, basically.
Thank you very much. A very comprehensive answer. Since this is like a super important topic, and many people are very curious about this, Dr. Thomas, would you like to add any comments on this about the benchmarks?
Sure, yes. Paul's response was very thorough, so I don't have so much to add. I think I will echo, measuring like size and deployment inference time, that's something that it would be great to start seeing in all the benchmarks you guys produce. But I'm not going to go through all of the details that he just said. I think those were great suggestions. I think one more thing that I would think about is adaptability. So something that I think would be really interesting to see in benchmarks is a separation a little bit of how well, given a specific image, how well it can detect, your model can detect some defect on the set of images that you have, and then how well that same model can adapt to or can without additional training, let me be super clear, without additional training, how well it might detect that same defect on a slightly different surface. So surface textures or devices altogether, either one of those I think is very interesting. The other thing that I think about a lot in my work is how well your model might adapt to a new defect type. So these models that include an inherent classification that's not binary, so a classification of what defect type you're seeing. Sometimes in a real manufacturing setting or in a real industrial setting, you may have new defects that arise that you don't know are coming ahead of time. And you may be misclassifying those from the start. That's not something that we want. And so I think something that would also be really valuable in a benchmark is how well does the model that you trained perform on new defect types. So how well does the model that you trained perform on new defect types that weren't in your training set? And how well does it perform on new surface types that weren't in your training set? We can actually tease those two things apart, and we can have a really clear metric when you like submit your benchmark measurements. I think it would be great to see both of those. Adaptability, I think broadly like means a lot of things. So testing, as Paul mentioned, against different like lighting conditions, like some of the common things that do change in industry is also great. Different framing, zooms. We've seen some of this work here. So I think people are generally thinking about some of these problems, but I wish there were a more standard benchmark sort of set of tools and tests that people were running on the models that they build. I know there's a lot of temptation to just focus on the ones that your approach or your model is doing really well. But from my perspective, it would be great if people could share both the things that your model or your approach is doing really well, and also maybe the ones where you know there's still more opportunity to continue developing.
Thank you very much again to Dr. Berkman and Dr. Thomas for their comments on this topic. So I would like to raise the last question that we have selected from the questionnaire to Ms. Shanhari Sivaknana-Sandaram. The question is about sustainability in manufacturing. So what do you think about sustainability in manufacturing analytics and infrastructure? Can advances in industrial inspection, I think that we will be very happy to hear your comments. Thank you very much.
Yeah, I'll keep these brief. So yeah, I do believe that the sustainability will come from being able to do things efficiently and not repeat different parts of repeat different actions across the supply chain. And that is a theme that's really, integral for us. When you're at the end of a supply chain, you want to make sure that you get the benefit of everything that has happened before. So with respect to visual inspection and inspection in general, what we see is that those images are going to be captured and they can be used not just by yourself, but your customer as well. And the customers can also benefit by taking images that have been captured, analyzing them, and then coming up with an understanding of the product that is much deeper than you would have been able to do at the node of the supply chain that you're at. So that's how we see the value of being able to use images and image analytics across the supply chain. Yeah. So, yeah.
Thank you very much for your comments. I unless there are additional comments, I think we can wrap up the panel discussion. I would like to thank all panel members again for their valuable insights and comments. So thank you very much.